Hello again, this is structural analysis made fun and easy. We're not doing any structural design today. This is part 2 of 3 of videos on University of Bolton School of Engineering, Civil Engineering Semester 1 exam 2015-2016, unit module number CIE 5004. This is statical determinacy equations of equilibrium, method of section, plane frames, portal frames. So in part 1 we found the reactions for this plane portal frame with a pin in the middle of it. The trick was to use method of sections about the pin in the frame. So hopefully you liked the first video. Please like this video and subscribe to the channel. Please donate if you can to make more, so I can make more videos like this. So let's get on with the next bit. The next bit is to find. So it actually says question part A was to find the reactions. We found them. RAH was 27 to the right. HA was 27 to the right. HE is 81 to the right, RAV is 72 up, REV is 72 down. So we found them in part 1. So now on to, it says, actually part B was to find the actual forces and part C was to find the shear forces, but I like to do the moment first. So basically I'm going to do part D first. Exam technique, 6 marks allowed. 6 times 1.8 is 6 plus 0.8 divided by 6 is 6 plus 8 times 6 over 10. 8 times 6 is 48. 48 over 10 is 4.8. That's 10.8 minutes. As we also know now, there are 3 positions where the moment is 0. They are at A, C and E. So let's start with member AC. Now we can use our trick again. Our moment's about point C. That must equal 0. Method of sections. Point C, 0. So moment at C. As we worked out, moment at C is 0. Moment at B is therefore equal to the reaction at RH 27 times 5. Because if we take moments, what we're doing basically is, taking moments about everything that's underneath. Point B. So let's do that first. 27 times 5 is 100 plus 35 is 135. And then we could double check this goes back to 0 at point C. So then we've got 72 times 3 minus 27 times 8 is 210 plus 6 minus 160 plus 56. 260 minus 216 is 0. That's okay. So that's correct. That balances out. So the other way to check what the moment is about B, we could take moments about everything above point B. So there's member forces, because there's obviously, remember, there's going to be this green reaction, that's the vertical reaction at A, that's going to turn into a shear force in member CD, and the horizontal reaction is going to turn into an axial force in member CD. The axial force is going to be 27 minus 72 equals 45. So the moment, we can double check the moment at B, that's 45 times 3. That'll be clearer again when we do the axial force diagram. So that's it. We have the bending moment diagram for member A, B, C. So it goes 0, 135 and then back to 0. That part's it. So that is 6 marks. So let's move on. Oh yeah. So here now I haven't done the right hand side. Let's move on to right hand side. Now let's start at B. So we go method of sections about pin joint C. So there's a reaction from HA, that's 27, and the vertical reaction from A, that's 72. So the moment at point D, let's take moments everything to the left hand side of point D. So so MD equals 72, which is the vertical reaction at A times 9. 72 times 9 is 630 plus 18 is 648. Let's check that by taking moments about point D, everything underneath. REH times 8 is the moment at D. 81 times 8 is 640 plus 8, 648. So that's correct because it balances out. Because if we take moments about D, the 36 force is is parallel. So that doesn't have any lever arm, so that doesn't do anything. The same thing with REV. So it's parallel. And the same thing with RAH. So basically that means we have the bending moment like this. So MA is 0, MB is 135, MC is 0, MD is 648, and ME equals 0, and it looks like this. I haven't colour coded this one, but the other ones were colour coded. So that's it, that's 6 marks. Then we go on to, well, this was actually B in the question. Draw the shear force diagram. Shear force diagram, 4 marks. So it's 4 times 1.8. 4 times 8 is 32, divided by 10 is 3.2, so it's 7.2 minutes. So when you do the shear force diagram, all you've got to do is start at A. We got the horizontal reaction, 27 to the right. Then we go up to where the point load is, that's 72 kilonewtons back. So that means from B to C, there's a shear force of 72 minus 27 is 45. So you'll see in the next part that 45 then becomes an actual force in CD. There's a pin there. Just need to put that in there. There's a pin there, and the pin this one. So the shear force in CD is the vertical reaction. The vertical reactions from A and E, so it's 72 kilonewtons. So it goes up, along, and then down. So that's just a block, 72, and then the shear force in member DE is 81. Oh yes, 81 goes from reaction at E, 81 along, 36 back, and then 45 is 81 minus 36 is 45 again. That 45 is an actual force in CD. So I think it was actually part C, wasn't it? Maybe it was C or B, but now it's pretty easy, this question, isn't it? Draw the actual force diagram. Exam technique is 4 marks, that's 7.2 minutes. So if we start, say, at A, then the actual force is compression is 72 kilonewtons from A to B and B to C. So the weird thing about this question is that from C to D, the actual force is actually in tension, which is a little bit weird, and so is DE. So the actual force is equal to, so we got 27 plus, as we were looking before 27 minus 72, and then so that actual force must be 45, because it's 27 minus 72, tension 45. Check that. 81 minus 36, 45 tension. That's correct. So that is 45 tension. And the final actual force is from D to E, that's 72, that's tension, and then that 72 goes into a shear across CD. So that's the entire question. Oh no, sorry, there's one more bit. I'm going to do that in part 3. So this was Bolton University Engineering Exam Paper CIE 5004, Statically Determinant Equations of Equilibrium, Method of Sections, Portal Frame Part. This is part 2. Please like the video and subscribe to the channel. Please donate if you can to let me make more videos. So if you have any questions or comments, please just leave it in the comments below. Yeah, the last bit is the last part of the questions is they move the hinge from C to D, but I'll do that in the final part. Let's put that one in there. Okay. Thanks for watching. Hope you enjoyed the video.